simplifying expressions to start with, and then we'll move to equations. And again, guys, this is just like a recap, revision, consolidation of what we have done. So if you are new, you can go back and rewatch the videos, but basically this is what we have covered in this course. Right now, don't stress about the questions. I'm going to zoom in on each question so we can see. I just want to have a look at what is in this little block here, because when we are simplifying expressions, there's three important things we need to remember. So when we do this, we want to be able to identify the terms that make up our expression so that we know what we're working with. We want to be able to simplify each of the terms. Sometimes this is necessary because a term might be multiplied by something, or it might be divided by something, or it might have an exponent we need to deal with. So we need to be able to simplify each individual term. And once everything that can be simplified is simplified, we can then go and simplify the whole expression by grouping our like terms and then adding and subtracting our like terms. So if we can do those three things, we should be sorted for simplifying expressions. Okay, so I'm going to have a look at these questions. We're going to start off nice and easy. If we have a look at our first one, we've got 3x plus 2 plus 5x plus 4. So if anyone's feeling brave, please raise a hand. Otherwise, you can pop it in the chat. How many terms am I working with in this expression? So how many terms do I have here? Lolita. Want to tell us?
4 terms.
Awesome. Now, Lolita, can I ask I need to phrase my question in my head. How do I identify my terms? So like what separates terms? What do I look for?
Plus signs, subtraction signs, or equal signs.
Awesome. Okay, exactly. So guys, when we have an expression, the plus and the minus signs are what separate our terms. Equal signs then come into equations, but for now we're just looking at expressions. So the plus and the minus signs here in this expression is what sort of demarcate or sort of separate my terms. So that's how I know I have 4. I've got 3x, I've got plus 2, I've got plus 5x, and I've got minus 4. So well done everyone on the chat as well. Awesome. 4 terms. Okay, so now I know what I'm working with. The next thing I want to check is, can I simplify any of these terms? Is anything being divided? Is there any multiplication I need to deal with? Stuff like that. Looking at my terms, nothing, like no individual term can be simplified. So what I mean by that is, if we look at 3x, I can't simplify 3x. 3x is 3x. That's it. So I can't do anything with that. So what I can now do is start to collect my like terms. Now, when I do like terms, I always highlight them. You don't have to, you do it how you want to do it, but I'm going to highlight my like terms for myself so I know what I'm working with. All right. So like terms, remember guys, are terms that have the same variable and exponent. So here I've got a term with an x in it and another term with an x in it. So those would be like terms. And then I've got my 2 constants, the plus 2 and the minus 4. So those now form a separate group of terms. And what's really important is that we remember that unlike terms can't be added or subtracted from each other. So we keep them in their groups. Now, if it's helpful to you to rewrite your expression with your terms grouped together, that's absolutely fine. So if you want to write this as 3x plus 5x plus 2x minus 4, so just keeping your like terms together, that's cool. If that helps you, do it. And now we just add and subtract. So 3x plus 5x is 8x, and positive 2 minus 4 is a negative 2. Those aren't like terms, so I can't subtract the 2 from the 8x because they're not like terms. And so that is my final answer. Right, Naledi, yes, you do get a negative answer, so that's why I've got a negative 2. Okay. Oh, Onati, I think if I understand your question correctly, you're talking about those 2. Those are called constants, as Brenda's just said on the chat. Well done, guys. Okay, so take a screenshot if you don't have that, but we started off nice and easy, just collecting our like terms. And that's really important when we simplify expressions, being able to collect our like terms.
Well done, my people.
Right, so let's have a look then at question 2 over here. So question 2, again, we've got 4 terms here. I can't simplify any of the individual terms. So what I want to do now is I want to collect my like terms. So I'm going to give you guys like a minute or two. I would like you to simplify this expression. So you need to go and find your like terms and add and subtract them for me. And if you're feeling brave, I'd love to hear from you. So pop your hand up. Otherwise, you're welcome to pop it in the chat as well. Got it, guys. Okay, remember those like terms. That's what we're looking for here.
You got this, my people. I'm cheerleading you. I'm a cheerleader today. I got you guys. You'll do great, my people. The lady is like, I'm ready, ma'am. Whenever you're ready.
Okay, Naledi, do you want to tell us?
Okay, we're all yours, Naledi.
Ma'am, I'm not sure about this one, but ma'am, I said 10x plus 2x minus 3x squared minus 7x, and that equals 12x minus 4x squared.
Okay, Naledi, I'm so sorry. I knocked my computer. Can you start again? I'm going to follow you now. Tell me.
Ma'am, I said 10x plus 2x minus 3x squared minus 7x
Okay.
equals 12x minus 4x squared.
Okay, so have a look at our like terms here. Oh, golly, Miss Molly, everything's going wrong. Our like terms here are the x squared terms and then the x terms. So those are 2 separate groups of terms. So when, or if we want to group them together, we'll have the 10x squared minus 3x squared as one group of terms. And then we've got the plus 2x minus 7x. So those are the terms I want to be adding and subtracting. So 10x squared minus 3x squared gives me a positive 7x squared. And then 2x minus 7x is negative 5x. So just make sure we're adding and subtracting the like terms, okay? Okay. Right, so guys, collect your like terms, make sure you add and subtract them. And it's very important that in this case, we had x's and x squareds. So the x and the x squared terms actually form separate group of terms. They're not like terms. So we need to keep them separate when we go and add and subtract. Okay. Right, so have a mark or take a screenshot. I'm seeing some great answers in the chat. Well done. You guys are doing awesome. And let's have a look at our third question. Oh no. My laptop's fighting me, guys. I apologize. There we go. All right, question 3. Now we need to be careful here because we've got a little bit going on. So we've got negative 3 times x minus 2 times y plus 5y. So my first question I'm going to ask you guys is, if we look at the whole expression, how many terms do I have here? So you can pop it in the chat or you can raise your hand. How many terms am I working with in my expression? Awesome. Lolita, do you want to tell us? Oh, no, sorry. Okay. Caden's hedging their bets here. 3 or 2. Right, guys, we have 2 terms. Now, the 2 terms are the negative 3 times the bracket times the y, because that's all multiplication. Yes, there's a negative with the 3 and a negative inside the bracket, but that negative 3 is being multiplied to the terms in the bracket. So that's one whole term. And then my plus 5y is my second term. So those are the 2 terms that I'm working with. Now, remember, when we have a situation where we've got a coefficient in front of my bracket and at the end of my bracket, what I can do is I can put them both at the front. So I can rewrite this as negative 3y times x minus 2 plus 5y. It means exactly the same thing. And the reason we want to do this is because now I can see that I actually need to simplify this first term. So I actually need to multiply the negative 3y with the x and with the negative 2. I need to simplify it. Okay, so once I multiply, then I can start finding my like terms. So what I'd like from you guys is just to do that multiplication for me. If you want to go the step further and you want to simplify the whole thing, that's fine. But I would like you to just go and multiply or simplify this first term for me. Right, and if you're feeling brave, you're welcome to put your hand up or you're welcome to pop it in the chat, your distribution. Okay, so we've got some questions here. Oops. Okay, Ayanda, you're going to tell me what this answer is here.
Hi, ma'am.
Hi.
Ma'am, it is going to be negative xy negative xy and 6y
Perfect.
plus 5y.
Good, well done. Okay, so guys, when we multiply the negative 3y into the bracket, if you want to do your little multiplication block, go for it. If I just do this on the side so we know what we're talking about, negative 3y times x gives me, and of course I don't leave myself enough space, gives me negative 3xy. And the negative 3y times a negative 2, remember negative times negative is a positive. So positive 6y. So that's where I get these first two terms from, just from distributing. And then my plus 5y at the end. Now what I need, maybe I should put plus, sorry. Now I need to collect my like terms. This is where you can grab a highlighter or a pen or however you want to do it. We've got a term with x and y in it. And then we have terms with just y in it. So those form separate groups of like terms. And so now when I go and add and subtract my like terms, the negative 3xy, shame, he doesn't have any like terms, so he just chills there. But then 6y plus 5y is positive 11y. And so my answer simplifies to negative 3xy plus 11y, which I'm seeing coming through, which is awesome. Well done, everyone. Naledi, do you have a question?
Sorry, ma'am, I forgot to put my hand up.
No problem. All right, so really important is that we remember to distribute into my bracket first. That's the first thing I want to start with, because that then allows me to go and eventually find my like terms. I don't know if I'm saying your name right, Wavhudi. You can correct me if I'm saying it wrong. Do you have a question? You're going to need to just unmute yourself. Just click on the little thing that says unmute.
Okay. Sorry, ma'am. I attended the class late, so I don't quite get this. The question I would like to ask is, because it was negative 3y and in bracket it is x, which makes it negative 3xy. What needed negative 3xy? Like, ish, ma'am, this thing, I'm so sorry. I feel like I'm asking a dumb question.
It's okay. So
But
ask me the last part again. What are you asking me about the negative 3xy?
Yes, ma'am. I was asking that, how did it go from wherever it was to negative 3xy?
Okay, perfect. So basically, if we go back to the original question, right? In my original question, I've got a -3 and I've got a y at the beginning and the end of my bracket. Now, both of those are being multiplied. So what you can do is you can multiply the -3 in, and then you can multiply the y in, but that becomes complicated. You're doing a lot of multiplication. So what we do is we take the -3 and the y and we put it together.
Yes, ma'am.
That is then what we multiply into the bracket. So if you have a look over here, -3 times x is just -3xy. So it's just from multiplying the two together. And the same thing will happen when I say -3 times -2. By multiplying those two values together, I'm getting my +6y.
Yes, ma'am.
Does that make sense?
Yes, ma'am. I would say it does.
Okay, so it's literally, it's come from the multiplication. I have to do the multiplication first. If you think back to like BODMAS, we always do multiplication before we start adding or subtracting our like terms. So I have to do that multiplication first.
Oh, yeah, now I get it. Yes, thank you, ma'am.
Okay, good, well done. Okay, I see there's lots of hands. Guys, just quickly, just because I've my eye on the chat, we write it xy because that's alphabetical. Technically, a -3yx is the same thing, but we try and write our letters in alphabetical order, okay? So just bear that in mind. Okay, here's our next question.
Ma'am,
Hi.
Ma'am, I also wanted to ask about the XY, but it's fine, ma'am, I got the answer.
Well done. Okay. Manzile, got a question? I'm sorry, I'm going to interrupt you. Can you speak closer to the mic? Okay, so Benzile, I can't actually hear you. So can you try type it in the chat? You can send Yolanda a direct message or me, or just put it in the chat and we can try help you.
Yep, Sebenzile, we can do that. Just type it on the chat and then we can help.
Okay, guys, awesome. You're doing so well. Right, let's have a look at this fun scenario that we have going on in question 4. Now, we don't like fractions. Fractions are gross. Ugh. But we need to be able to deal with them, whether we like them or not. When we are trying to simplify fractions, one of the useful things that we need to remember is that any fraction that's written over one denominator, I can actually separate the fraction. And that's quite useful to me when I'm trying to simplify. So what I mean by that is that each of these 3 terms in my numerator, I can actually write as separate fractions over the -2. So this can be 2x squared divided by -2 minus 6x cubed divided by -2 plus 4 divided by -2. And so that's really helpful to us because now rather than stressing about, oh my gosh, I don't have like terms in the numerator, how do I do this? If I deal with each fraction individually, I can now simplify. Okay, so those of you who have been in the lessons before, you will hopefully remember SNV. If you are new, SNV is not the naughty thing that we know from movies and series. SNV is a reminder of accurately simplifying terms. And this applies for multiplication and division. So S is signs, and you'll see what I mean now in a second. N is numbers. V is variables. So basically, if we consider each of these separately, when I multiply or divide, I should always get it right. So let's have a look at our first fraction. So I'm just going to circle it so we know what we're working with. So this fraction I've circled in blue. Let's start with the signs. What is a positive? And you can put up your hand or you can pop it in the chat. What is a positive divided by a negative? What sign should I get when I've got a positive divided by a negative? Sadie, you want to answer for us?
You get a negative.
Awesome, well done. So positive divided by negative is a negative. So that's my S part sorted. Signs, done. Then I move on to my numbers. What is 2 divided by 2?
It's 1.
1. And then I move on to my variables. Now, x squared is not being divided by another variable. So it actually just stays x squared. That's it. Alrighty, well done. And now we can do the same thing for the other 2 fractions. So now when we move on to our next fraction, just remember that there is a negative with the 6x cubed. And so now when we do the signs, we need to remember that a negative divided by a negative is a positive. So that's the sign sorted. Numbers, 6 divided by 2 is 3. And again, I'm not actually dividing the x cubed by any other x's. So it just stays x cubed. And then we move on to our very last fraction. Now we're quite lucky here. We don't have any variables that we need to stress about. It's just the signs and the numbers. We've got a positive 4 divided by a negative 2. So positive divided by a negative, we already know is a negative. And 4 divided by 2 is 2. Okay, so I'm just going to write this out so that we don't have all these colors and you can see what's happening. So I've got a negative x squared plus 3x cubed minus 2. So now we need to ask ourselves, do I have any like terms here? So someone can maybe tell me, do I have any like terms in this expression that I currently have? Lolita, tell me, do I?
Yes.
Do I have like terms with negative x squared plus 3x cubed minus 2?
Yes.
What are your like terms then?
Negative x squared plus 3x cubed.
Okay, now be careful. Remember, like terms have to have the same variable and the same exponent. So because those exponents are different, they're not like terms. Okay, so we just need to be careful of that. And so I don't actually have any like terms here because I've got an x squared, an x cubed, which is now a separate group, and then my constant of negative 2. So no more like terms. That is my final answer. Alrighty. So guys, just be careful when collecting your like terms, same variable and the same exponents. Okay, so if that had been a negative x cubed plus 3x cubed, absolutely. But the exponents are different, so we just need to be careful of that. Okay, you guys are doing so well. Well done. All right, take a screenshot if you need. And let's have a look at our 5th one here. Whoopsie daisies. Okay. Question 5. So we've
You
got
guys
a
are
bit.
doing great.
You are. So we've got a bit of distribution going on here. Now, what I need to be careful of is if I look at my whole expression, I have 2 terms. I've got the 3 times the bracket and the negative 2 times the bracket, which means that I need to simplify each of these. So I need to multiply the 3 into the first bracket and the negative 2 into the second bracket. So I'd like you guys, I'd like you guys to try this one for me. I've given you a little clue of what you need to start with. You need to start with multiplying into the bracket. So I want you to simplify question 5 for me. And if you're feeling brave, pop your hand up and it's here. Otherwise, you're welcome to just pop it in the chat for us. Got it, guys. Right, and remember, if you need to, sort of as Caden's starting to do in the group here, do your multiplication step by step. There's no need for you to go straight to the answer. Go step by step and make sure you're feeling comfortable with each step that you're doing. Oh, sorry guys, I just need to blow my nose. And guys, remember when you're multiplying, especially when you start to multiply that -2, be mindful of what happens to your signs. I see some hands up. I'm hoping that's to answer. Linda, do you want to pick our lucky number who's going to answer our question for us?
So I have talked to Naledi, then Holofelo, we
Okay.
are all yours. Naledi, we have seen your voice. We're just spreading some love. Hi, Holofelo. Would you like to tell us
Hi.
what? Yeah, you can work this question for us.
The first thing you do, you say x 3 times xy, and there's an invisible one before the variables. You say x times y is equals to x3 is equals to 3xy minus 3 times 7 is 21y.
Good.
Then minus 2 times 2
Good.
equals to 4y.
Awesome.
Then -2 times 3 equals to -6xy.
Awesome. Well done. Do you want to keep going?
Yes, ma'am.
Okay, cool. Let's hear it.
Then you say equals, you find the like terms, which are 4 and 21 and 4. You will subtract 21 and 4 because they are like terms. And 21 minus 4 equals to 17.
Okay, so just be careful. It's -21y minus 4y. So they're both negative.
Oh, so I add, which is 25y.
Okay, so -25y. Good.
And then the other like terms are 3 and 6. Then I will add them, which will give us 9xy.
Okay, so again, just be careful. It's 3xy minus 6xy. So what happens when I take 6 away from 3?
It will give us -3.
Awesome, well done. Okay, guys, so we've got -25y minus 3xy. Now, if you've written that slightly differently, so if you said -3xy, whoops, minus 25y, that is absolutely fine. Okay, both are perfectly valid. Both represent the same answer. So if you've put your terms in the other order, that's absolutely fine. Don't stress about that. Right, well done. Scarlett, do you have a question?
Yes, ma'am, I do. Thank you for answering. Ma'am, I was just wondering, for that specific question, I'm confused about, like, it says here, -2. So I see it in brackets -2 times 2y. So isn't it supposed to be a plus? Because I'm not sure.
Okay, so just remember that this negative is attached or belongs to that 2. So when we multiply in, we're multiplying in a -2. If you wanted to think of it slightly differently, what we could do, let's just make this a bit smaller. How you could think of this is negative and then sort of imagine it as 2 times the bracket 2y plus 3xy. And so then you could multiply the 2 into the bracket, leaving you with 4y plus 6xy. But then you still need to multiply the negative into that bracket. So it'll still take you to negative 4y minus 6xy.
Oh, because ma'am, I normally do is I put a minus outside the bracket and in because it's a negative number. So.
Okay, so what you need to be careful of there is if you put two negatives, what happens when I've got a negative and a negative?
It turns into a plus.
Right.
Yeah.
So what you're doing is you're actually changing the expression. You're making it plus 2 times 2y plus 3x, and it has to be minus. So that's why I'm saying you're welcome to keep the minus outside the bracket, but then you're not going to put it with the 2 as well. It's just going to stay outside.
Oh, okay, I see. Thank you so
Okay.
much.
Pleasure. Sadie, do you have a question?
Yes, ma'am. So in this one, when we don't do that, okay, we don't have to change the signs, man, like the one we put on the previous lesson.
Sorry, Sadie, can you speak a little bit clearer or like move the microphone a little bit? You're just a little bit muffled.
Can you hear me now, ma'am?
A little bit better?
Okay, ma'am, I wanted to say, ma'am, in this one, we don't have to change the sign into like, when it's a negative, we don't have to put it into a positive.
Okay, so when you're talking about changing the sign, are you talking specifically about the negative 2 here?
No, I'm asking like on the previous lesson, what the inverse or the
Oh, sorry. Right, with you. No, because we're not solving an equation. We're just simplifying right now.
Okay. Thank you.
Okay. Pleasure. Right, guys, well done. Okay, so let's take a little brain break. Those of you who are new, don't stress about the brain break. All it is we're taking a break from maths. And so basically my brain breaks change every time depending on my mood. You always get a fun math stroke. And then this time we've got some riddles. So there's 3 riddles here that I want you to solve. First one, what has 13 hearts but no body? Second one, you go at red but stop at green. What am I? And I would just like to clarify, do not tell me it's a robot, because guys, you stop at red at a robot. The other class is telling me they go at red and I was very worried. And then the third one, I speak without a mouth and hear without ears. I'm invisible, but you can call for me. What am I? Now, if you don't get the brain breaks, that's fine. Get up, stretch, move your body, get the blood flowing to the brain. Just take a little break. And if you want to, you can put your answers in the chat or you can raise a hand and we can hear what you have to say. Brenda, do you have some answers for us already?
The first one is a deck of 10 cards.
Awesome, well done. Okay, so the first one, what has 13 hearts but no body, exactly as Brenda said, it's cards. A deck of cards has 13 hearts in that suit. Well done.
Well done, my people. Let's go. Let's see who can get the second one.
I'm also terrible at these. I'm so bad at riddles. It's not my strong suit. Naledi?
I mean, I got the second one.
Okay,
I
tell
think it's
us.
like a watermelon. Because like,
Yes.
I think it's a watermelon because you stop at like green after you eat the red parts.
Exactly. Well done. I'm so glad no one said robots. I was very worried. Well done. Okay,
Well
the third
done.
one harder. I don't think I would get the third one if I didn't know the answer. So third one, I speak without a mouth and hear without ears. I'm invisible, but you can call me. What am I? I'm seeing some of these answers and I think I would tend to agree maybe. No, lady?
Remember a ghost?
A ghost. Okay, interesting. I mean, yeah, that makes sense. Then Kosi, what do you think?
Hello, ma'am.
Hi.
I think it's a cell phone.
Right, I'm seeing also cell phone, which I also like. I think I could get on board with cell phone. right? I see also an echo on the chat. So Google's answer is an echo, but I think I could get on board with the ghost and a cell phone. That makes sense to me. Nice, guys. Well done. You're much better at this than me. I'm shocking at these. Right. Okay, make sure you've had a stretch. Kendra, are we stretching, my man? Kendra is our resident stretch instructor. Did you stretch? Okay. Right, guys, let us get on equations. Oh, golly. Right. So now we've been doing equations quite a lot. So I think those of you that have been in our lessons, you will probably feel a lot more comfortable with equations than the expressions, because we did expressions quite a while ago. So the equations we should be comfortable with. And again, obviously, if you're new and this is still new to you, that's absolutely fine. Don't stress. All of the videos are online. The ladies, sorry, before I carry on, do you have a question?
No, ma'am, I want to answer the first one.
This first equation?
Yes, ma'am.
Okay, so walk me through how we would do this.
Okay, so first, ma'am, would say 3x minus 2 plus 2 would equal 4 plus 2.
Oh, golly. Okay, yeah, keep going.
And then after that, ma'am would say 3x will equal 6 from the 4 plus 2. And then after that, ma'am, we can divide both sides by 3. 3x will be cancelled out by 3, and x will equal to 2.
Awesome, well done. On fire tonight. Right, guys, awesome. So let's just walk through this. Remember, when we solve equations, we need to use inverse operations. That's really important. Now, something like this, you might be able to look at and say, okay, I know the answers to without sort of doing all the working out. But as we start to deal with more complex equations, inverse operations is really important. So if you have been with us, remember we've spoken about the fact that we want to get the x terms onto the left-hand side. Now I'm lazy, so I'm going to say LHS left-hand side. I'm just lazy. And then we want to get the constant terms, so the terms without any variables, to the right-hand side. So again, RHS right-hand side. So what that means is that this minus 2, I somehow want to get to the left. The only way for me to do that is to use inverse operations. So when we are solving equations, inverse operations or the opposite operation is super important. We need to be able to work with those inverse operations to get our answer. So in order for me to get the negative 2 over, I have to do the opposite. So I have to plus 2. So that's when a lady said plus 2 on both sides. You don't have to write the plus 2 on both sides like I did. If you're happy to sort of do it in your head, that's absolutely fine. So what we now have left on the left-hand side is 3x. And then on the right-hand side, we've got 6 because 4 plus 2 is 6. Now, remember, the goal of solving an equation is to get x alone. So I want just that x. I don't want 3x, I want x. And so again, inverse operations comes into play. Originally, it was 3 times x. So the opposite is to divide by 3. And what we need to remember is that if I'm going to divide what's on the left by 3, I need to keep my equation balanced and also divide what's on the right by 3. So I have to remember to do it to both sides. And then once I divide 6 by 3, I end up with my answer of 2. Now you can always go check yourself. If you go and put this x equals 2 back into the x, you want to check that the left is equal to the right. So 3 times 2 minus 2, we want to make sure does equal 4. 3 times 2 is 6. 6 minus 2 is indeed 4. And because 4 is equal to 4, my answer is correct. So what's quite nice about equations is that you can go back and check your answers. So when you're sitting at the end of your test or your exam and you've got some time, go and check your answers to the equations. Right, so I see those x equals 2's on the chat. Well done. Take a screenshot if you need, and let's have a look at the second question. Okay. Right, so our second question, we've got 3x minus 6 is equal to 18 plus 5x. Now, we've just spoken about the fact that we want to try get our x's on the left and our constants on the right. So what that means is I somehow want to get this plus 5x over to the left-hand side, and I somehow need to get this negative 6 over to the right-hand side. So have a try, see if you can solve this equation. So solve for x. And again, you can put your answers in the chat, or you can raise your hand and we can hear from someone on how they solved this equation. All right, guys, you're doing so well. We've done a lot tonight and you're working so hard. Well done. Right, remember those inverse operations. Remember, we're solving for just x, so I don't want a coefficient next to it. And remember that if you are moving things over your equal sign, we need to be using those inverse operations. So remember to do the opposite of what it originally was telling you to do. Yolanda, I'm seeing lots of hands. I'm gonna let you pick who's gonna answer for us.
Lilita, we haven't spoken to you in a while. Lilita, is that a hand to answer?
Yes, ma'am.
Okay,
Let's go,
Lolita,
girl.
let's hear it.
So we're going to move the 5x to the 3x. So we're going to move it to the left-hand side, which makes it a minus. So it's going to
Awesome.
be 5x minus 3x is equal to 18 plus 6x, because 18 plus 6, because we move the 6 to the right-hand side.
Yes,
Good.
go.
So 5x minus 3x is equal to 2x.
Okay,
Then
Lolita, I don't want to, you're doing really, really well. Just remember, you move the 5x over, so it's a minus 5x.
Oh,
You're allowed to use your calculator, Lilita, and just check your answer.
okay, ma'am.
Okay, so just remember it's the minus 5x, not the minus 3x, but keep going.
It's a minus 5x minus 3x, and then
Plus
it's equal
3x.
to 8 plus 3x. Then it's equal to
Just
8.
exactly how you have written it on your book, the 3x minus 5x. So you can use it and check it on your calculator what you get.
Okay, so
And then
3x minus 5x gives me?
3x minus 5x is equal to, I wrote it 5x minus 3x, and I got 2x.
Okay, so because it's 3x minus 5x, I'm taking away more than what I had, so it'd be a minus 2x.
Okay.
Okay, cool, keep going. What happens with the 18 plus 6?
It becomes 24. And then in order to get the x on its own, we divide it by 2. And we do that on the other side as well by 24, which makes the answer
You got this, Lilita, you got it. Let's
sorry,
go,
ma'am.
girl.
So what's a
equals,
positive?
the answer is equal to negative 12.
Awesome, well done.
Yes.
Well
Well
gosh.
done, Lilita.
Yeah,
So
awesome,
proud.
Lolita. Well done. And well done on catching that mistake and correcting it. Awesome. Okay, guys, so exactly. When we bring the 5x over, it becomes minus 5x. When we bring this negative 6 over, it becomes plus 6x. And so we end up with 3x minus 5x equals 18 plus 6. Now 3x minus 5x is negative 2x. And then the 18 plus x, as Lolita told us, is 24. And then because we want x alone, we have to divide by a negative 2. And so remember, when we divide a positive by a negative, we end up with a negative. So I saw quite a few negative 12s. Well done. If you got a positive 12, just be careful of those signs, okay? Right, but well done, guys. Awesome work. Okay, take a screenshot, do your corrections. And let's have a look at question 3. Oops, whoops, whoops. Absolute chaos. Okay, question 3. We've got 2x minus 2 divided by 3 equals negative 2. So what we now need to be careful of here is we've got a fraction. Now, guys, anytime you have a fraction in an equation, we need to know what operation that's working with. And we know that fractions mean division. So when you want to start using your inverse operations, you need to remember that the opposite of division is multiplication. So in this case, because I've got the fraction on one side and then the negative 2 on the other side, I'm going to start by dealing with that fraction. Now, we've just said that the fraction is a division by 3. So I want to do the opposite. The opposite of division we know is multiplication. So I actually want to multiply by 3 because that's going to get rid of my denominator. But I need to remember to do the same thing on the right-hand side of my equation because I have to keep it balanced. If I start doing things on one side of my equation and I don't do the same thing on the other side, I'm throwing my whole equation out of balance. And so it's no longer accurate or correct. So once I've times both sides by 3, I get 2x minus 2 is equal to, and we know that negative 2 times positive 3 is negative 6. Right, so I feel pretty confident you guys can do this. So 30 seconds. I'd like to know what x is from you. And again, if you're feeling confident, chuck your hand up and let's hear. Uyanda, do you have a question?
No, ma'am.
Do you want to answer this question?
I'm still gonna finish it, ma'am.
That's fine. Cool. Guys, got this. Nice. I'm seeing hands. I'm seeing answers. This is great. You guys are on fire tonight. Remember those inverse operations. Remember, I just want x. So x equals something. I don't want that coefficient in front of the x. Nice, guys. Okay, well, Yanda, are you ready to tell us?
Yes, ma'am. The answer
Okay,
is x is equal to negative 2.
Okay, do you want to walk me through how you then solved it from the step I stopped at?
Yes, ma'am.
Cool, let's hear it.
So what I did, ma'am, was 2x is equal to negative 6 plus 2.
Awesome.
Then I got my answer, which was 2x is equal to negative 4.
Good.
Then I divided 2x with 2 and negative 4 with 2.
Awesome.
And that's how I got x is equal to negative 2.
Awesome, well done. Fantastic. Great, guys. So exactly. Once we've dealt with that fraction, life becomes so much easier. And so that's why I'm saying if we can deal with the fraction, let's do it. So once you've dealt with the fraction, sorted, we now just use our inverse operations that we used to, and we go and get our answer. Again, remember, guys, you can always double check yourself. If you substitute it back in, you just make sure that your left-hand side is equal to your right-hand side. And you make sure that if they are equal, you got the correct answer. If they aren't equal, you've probably done something wrong and you're working out. And so it gives you an idea that you need to go back and check. Right, well done, guys. Awesome. Right, let's do one more before we get the quiz. And if you're new here, the quiz is just a little quiz to help you practice what we've been talking about. Okay, so we've got 3 times x minus 1 is equal to negative 2x plus 2. So what we need to be careful of here is that I first need to go and distribute the bracket. So I need to do the multiplication first. So what that means is I need to multiply the 3 into the bracket to both the x and the negative 1. And once you've done that distribution, we then follow the usual steps like we've been doing. So 3 times x is 3x, and 3 times negative 1 is negative 3. So I've got 3x minus 3 is equal to negative 2x plus 2. And so once I've dealt with the distribution, life becomes easy. I know how to do this. I want to get x's to the left, constants to the right, and I can solve my equation. Right, so have a try. Hands up if you'd like to explain to us how you did it. Otherwise, you can pop your answer in the chat. You guys are doing really well though. Well done. Keep going. Oh, I'm seeing all the hands. Great, guys. You got this. Yolanda, I shall give you the honor of the last answer for our question tonight. Who is it going to be?
Sekiwa. Sekiwa, I nominate you. Let's go. Guys, I love you all. It's just names that I haven't called out in a while.
Hi, ma'am.
Hi.
Okay.
You can do this, girl.
Ma'am, first I said 3 times x, which is 3x. And then I also said 3 times minus 1, which is negative 3, equals to 2x plus 2.
Okay, careful, it's a minus 2x, eh?
Yes, ma'am.
Okay, cool, keep going.
And then I took the like terms, ma'am. I took 3x plus 2x.
Yes,
and then equals to 2 plus 3.
Awesome.
Yay.
And then I got 5x equals to 5, and I divided both sides by 5, and I got 1.
Awesome.
Nailed it. Well done.
Right, excellent, guys. Exactly, x is equal to 1. And so again, like what I think was really important to see from the last 2 examples is the fact that even if there's a fraction or even if there's distribution, once you've dealt with that, it's so much easier. And so that's what we need to get in our minds. If we have distribution or if we have fractions, deal with it first and your life becomes so much easier. Remember, you can check yourself by subbing back in, but I mean, you guys are on it tonight. You're doing so well.